Hello, let's wait a little bit until others join and then we'll start. Okay, I guess we can start. So today we're going to continue talking about the main principles and properties of object-oriented programming. First of all, thank you to those who submitted the, the assignments about the object-oriented programming. So today we're going to continue about the principles what are related to object-oriented programming, what are directly related, and they are practically used in almost all the programming languages where object-oriented programming is used. So previously we talked about the inheritance. We talked about the main principles of inheritance, that one class can be inherited from another. So we talked about the casting, and regarding the casting, just in case you maybe missed previous presentation, I can also share small, just a few slides about the about casting operations, so then you can take a look on it. Let me share it there. Yep. Here we go. So here you can find the presentation about casting. There are a few slides, but so just I try to explain the main things there. Yeah. So regarding the casting, basically regarding the inheritance. Yeah. So just what we need to know. We need to know that if we inherit from the superclass, then the superclass actually, then all the public. So the main thing is that then the subclass actually inherits. It basically inherits everything, but the accessible attributes and the methods for the subclasses are public or protected. Yeah, private methods and attributes, they are still inherited, so they are still in fact available for them. For the subclasses, I mean, they're not available, but they also will belong to the objects created from the subclasses. However, they cannot be accessed directly from the subclasses. But still, the fact is that everything is inherited. Yeah, not everything can be accessed from the subclasses, but everything is inherited. It means that all the methods, all the attributes, they all will in fact be available, not be available, but they all will be, let's say, active in act for the subclasses as well. So yeah, that's the thing. And yeah, so in this case we just need to understand, and the key thing to understand about the subclasses is that when the class is inherited from the superclass, then all of the objects created using the subclass are also considered as the objects created from the superclass. Yeah. So, and again, the key thing for the superclasses is that we have top-down design. So we go from top to down, and it means that employee is human, and in this case means that programmer is also employee, and employee is human. So we go from top to down. So everything basically goes down, down, down. It means that all the objects that are below one or another object, they will have all the same properties plus something more what can be directly defined in these classes. So that's the thing. That's the thing about inheritance. We gone through it during the past sessions. However, we also last time we also talked about the casting operation, and since again, what's the point here is? The point here is that as I said, for example, employee can also be human, and programmer can also be a human, and programmer can also be employee. So in this case, it is possible, and sometimes it is needed to use like the general data type, like let's say we say the general data type is human, to store the references of any subclasses. I mean, any level subclasses of this class here, let's say human. Then it means that we can pass the reference of the, for example, kid to the variable defined as human, and this will be correct. We can pass employee to human. This will also be correct, and then we can also pass programmer to human. That will also be correct, because again, programmer is human. So that is why we can do it for the subclasses. Yeah, so that's the point, and all these cases are called upcasting. So it means that we go up, yeah, from the hierarchy point of view, and so that's the easiest case of casting. It will always work. It will always be correct, since that makes sense when we talk about the casting. Since it means that all the kids are humans, all the employees are humans, so it's obviously that this should normally work. However, in some cases, so the upcast, it's quite a direct way, and I guess it should not trigger any issues from the understanding point of view, and it will never trigger any issues from the usage point of view. So it means that if you have the object defined, the variable defined as any superclass, then you can as a superclass, then you can pass the reference of the object from any subclass of this class. This will always be correct, and this will always work without any issues. On the other hand, we also have downcasting, and downcasting is more special and trickier way of using the casting, because it means that we go from more, like if we have, let's say, the variable programmer, and we want to pass the reference from the variable defined as human. In some cases, it may not be possible, but again, please remember one thing, and what I mentioned last time, and this is very important to understand, that the variable stores the object, the reference to the object, and the reference to the object may have the type which is not mandatory the same type as human. So let's say you have the case when you do the upcasting, you have the variable defined as employee and the variable defined as human. You have the reference of the object created under the variable employee, and you pass it to human. So this is correct. But on the other hand, you also want to then pass the same variable back to this employee variable. So maybe to this employee variable or to any other variable, it doesn't matter. But in this case, the question would be why I can't. So if we talk about only the upcasting, then the question may be why I can't pass it. So if I pass from employee to human, why I can't pass the same reference in the opposite direction. And in this case, this can be done, and this is what the downcasting is about. And again, as I just said, the variable stores the reference to the object. Yeah? And the type of the reference not mandatory to be human, as in this case I just explained. It can also be employee or programmer or any subclass of the class human. It can also be human itself. Yeah? human object itself. So that's not the issue. But again, in such case, we may need to pass the object back to the variable from where it comes from. Or just for example, let's say that we pass programmer to human, then we can also pass it means that the variable human will store the reference of programmer. It will not store the reference of human, employee, or kid, or whatever it is. It will store the reference of human if we pass the reference of programmer to human. It will store the reference of programmer. Then it means that this reference can be passed to employee, and it can also be passed to programmer. However, the type of the variable will be human. That's why we need to go, then we would pass from human to employee or from human to programmer, and this will be considered downcasting because it goes down. And it's obvious that if the reference type is programmer, we cannot pass it to kid because kid has no relation to programmer. So that's the point. That's the point, and that is when the downcasting is used. However, as I just said, we may have the issue that during the execution of the program, we don't actually know what's the actual type of the reference stored under the variable. And in this case, we have the option of checking this. Yeah, so it can be checked using try catch. So in case downcasting is incorrect, so it will trigger cast exception, special exception. Then we can handle it using try catch, and on the other hand, we can use is operator, and then we can check some if some object is the exact class or the subclass we're looking for, then it means that the casting can be done. Otherwise, we don't do the casting. So this can be checked. So this is from the previous session, what we were talking about. If you have any questions about the casting, please let me know. And today we will be talking about the abstract classes and interfaces. So first of all, before we start talking about the abstract classes, I would also like to remind you about the virtual methods and about the method overriding we talked before. So previously, again, the most general case we use was the method public static void to string, the static public void public string to string, yeah, which will basically return the description of the object as string. And as you've seen before, we use override. It means that this is method what comes from the superclass, and the superclass in this class is not defined, but that's fine for all the objects. Yeah, so you can point it here. All the objects. I mean, not all the objects, all the classes. All the classes in C# are actually inherited from object class. So that is the name of the class here. That is object class. And so here so if we know that all the objects are inherited from the class object, what does it mean from the casting point of view? It means that so on practice we can cast all the objects in C# to the variable tagged as object. Yeah, so that would be like let's say that here I have I can use the variable type object, and then here I can pass any object I want. Yeah, so object and currently inside the object. So that's why this is also type, but I mean all the references from all the object types can be passed to to the variable type as object, since this is the superclass for all the classes. Yeah, we do not write it directly, but it is done this way. Yeah, so and that's why here we have this method toString, which basically comes from the superclass, yeah, from the class object, and here we override it. Yeah, so this is what I'm saying. It means that if something is, again, remember, we have protected and we have public methods which are available from every class. I mean, from every subclass. Yeah, from every subclass, we have public methods defined in any levels of the superclasses, and also protected methods defined in any level of the superclasses available to be used in every method, or in every method of the class. Yeah. So in every non-static method, every instance method of the class. And yeah, this is why we actually can use them. That's first thing, we can call them, yeah, pass any parameters, return the value. So just use them the same way as we can use any method. Plus, we can actually override them, and it means that we can change their behavior. Yeah, so like if we don't override, it means that the method toString will be actually called from the superclass if it is called. In this case, if I override it, it means that the logic exactly defined in this class will be used, yeah, instead of logic from the superclass. And the same can be done from any class. Yeah, so the same can be defined in any class. So let's say that here I define the method. Let's say that will be public, and that would be, let's say, yeah, of course it should be virtual. Yeah, if it's not virtual, I cannot override it. And here I type override, and this would be void, since I will not return the type and not return the value from it. And here I can say that, oh, yeah, public void, and here I need to define name. So let's say play, and here I can just do some action. You know, let's say that I'm saying that the person is playing. Yeah, so here I simply define one method which prints something on screen. Yeah, I can define any logic here, so this logic is just for understanding. And then let's say that I take any subclass. So let's say that's the subclass programmer. Yeah, so oh no, that is taken from employee, but however it does not really matter. Here we go. Main classes opened. Okay, so there we go. So here we have the class. Close some applications. Give me some time. I will close them. Moment. I need to close some applications just to make my computer faster a little bit. Okay, so here we go, and yeah, so we have employee class. So it means that since this is public method I just defined, it will be available for any subclasses. Plus, I can also call it from outside the object. And so here I can override this method. So here I need to class override and public override void play. Yes, so again, that's the class defined, or that's the method defined in the class person. However, I can use it under the so public virtual. Sorry, not override, of course, a public virtual wait play. And so here I have it, and then I can use it from. I can redefine it here and write something else there. So there we will have it. Right line, and so here I can say that the employee is my okay, so let's now we can call the method. So we have person. Yeah, so here you can see that we have person employee as the person. So here I can, let's say, print some information about the employee. Not to print, but to ask employee to play. And so do I have person class? A person object defined somewhere? No, I don't have. And that's why, let's say that I printed, for example, here, person. Oops, I define person object here. Name being something like that. And yeah, so I can not the right one. Person object be this one, and so here I can ask the person to play. And so let's see how it works. So let's change the folder here. Okay, that's one more folder in between. So here I change the folder, and here I can run the program. It's running. Yeah, it's sagging code a bit. It calls more programs. Okay, just warning. That's not the problem. Okay, so here I can just tab the value for the previous. Yeah. So here we can see that first we have the employee is playing, and here I have that the person is playing. And in fact, so maybe I can, just to make it more obvious, I can then put it here. Person's blank and here employee is blank. So, and now the question for you is what will happen if I simply comment this code? So what will happen now? Question to you. So if I comment this code inside if I don't override the code, what will be printed for employee? When I call the method play from employee, what will be printed then? Do you have any idea? So as usual, we win and I have nothing. No, that's not correct. Again, please remember what I said. All the methods are inherited from the superclass. Yes, that's correct in the original method, because all the methods are inherited from the superclass, and the idea of the overriding is that we change their behavior. If we don't override, then behavior stays the same. And so that is the point. So let's run the program again. Let's change the story for Jack Sparrow. Yeah, so we can see that the original method will be in place. So that's the point here. And this is practically how all the overridden methods work. Yeah. So if nothing is overridden, then the method from the superclass is called. When we have, like, let's say, the hierarchy of multiple subclasses, like I said, as we mentioned last time, there can be unlimited number of the subclasses. Yeah, so the hierarchy can be as deep as we want to define it. So, and in case we define some method, and again, if it's public or protected method in human class, so then if it's not overridden in employee class, not overridden in programmer, then for programmer it will also be the same as in human class. Yeah. So just all the methods go down, down, down as well. They all uninherited and they all go down. In case we have defined the method, just any method in class, public protected method in class human, then we have the class employee. Here we override it here. We override the method here, but we don't override the method, this method on the programmer class. Then for programmer class, this will be the same as for employee. Yeah, so just again, everything is just taken from top to down. Yeah, all the methods go down, 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 down. And if something is overridden in the middle, then the overridden version will also go down, 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 and it will be used for all the subclasses. Right, so this is the idea. Do you have any questions about the method overriding? Yeah, and please remember that that the method should be defined as virtual. Yeah. So here you can see that we define the method as virtual, otherwise we cannot override it. That's just the point if the method can be overridden or not. If the method is not defined as virtual, then the method will be inherited. Yeah, it will be inherited for all the subclasses. However, it will not be possible to override it in the subclass. So that's the point. this point. Do you have any questions? So the method overriding is important point, since we will now jump to abstract classes and interfaces, and then it is very important to use, to be able to use them. So is it clear? Is it not clear? Maybe any questions about the method overriding? There are two terms. There's method overloading and method overriding. Please do not mix them. These are two different concepts. But yeah, method overriding works this way. Okay, just in case you have any questions about method overriding, please let me know. So yeah, this is about method overriding, and now we can jump to the after classes. So first of all, what's the abstraction is and why do we need it? So here you can see that we have a class person. We have the class person, but just let's imagine that we cannot use we cannot have the object person. So just we have the class which defines the structure of the person itself. Yeah, there should be the name, there should be parameterized constructor, there should be some methods and so on and so on. But let's say that the class itself, the class person cannot be used as the object. Yeah, so it means that we can create, let's say that we want to create, and we can create the object employee. We can create the object kit, but we can't create the object person. Yeah, just because we want it to be done this way. I mean, in our case, that's maybe not so obvious, but in some cases, we just may have such situation when the class cannot simply be used as the direct object. We must extend this class to then be able to define it, to use it for creating the objects. Yeah? Like in this case, let's say that we have the class human, but the only list of the objects we can use is employee, kid, and programmer. Yeah, so let's say programmer, human, it must define the structure of these all, but it cannot be used as the object itself. It cannot be used for creating the object as itself. So, and this is why we have we need to use abstraction. Yeah. So why abstraction is needed? Can we work without abstraction? Of course. Here that's such case. But remember that abstraction is something additional. That's the additional feature what we can use. And so that's maybe not the direct case when you must use something, but that's the case when you can use, and then you can achieve abstraction. Why it is needed? Yeah, so why the class can, let's say that why the class cannot, in some cases it cannot, why we want the class, we want to have the situation when the class cannot be used for the object creation. So there may be different situations, but first of all, as I mentioned several times, this can be done because of the design reasons. Yeah, so just from the design perspective, we want to point users to something. So the same is about private attributes. Yeah, so private methods. So you ask, why can we just simply define everything as public and just simply use it as we want? Yeah, first of all, of course, because of the some safety reasons, yeah, because of some flexibility what we want to achieve. But in addition, that's also the design pattern. We want to point to to those who use the code that private entities and private methods are the members which should normally only be accessed from the object itself without any touching from outside. And the same is here. The same is about the abstract class. First we want to point to the user that the class should not be used for the object creation. Yeah, so that's the first point. That's the first point. The abstract classes cannot be used for creating the objects. The subclasses, yes, if the subclasses are not abstract classes, they can be used for the object creation, but not the abstract classes themselves. So by that point, is it clear, or maybe something? I will show the examples, but the key point is we cannot create the object from the abstract classes. So by now, if you have any questions, please let me know. So that's the point. That's the point, and maybe for this case, let's also implement it. So just maybe to keep the commented code here, just for you to then be able to read the code, I will define it here. So to define the abstract class, I need to simply type as an abstract. So right now, at this point, so based on what I said, at which point will we have the errors? So to those who follow. So if I, based on what I just said, and based on the fact that I defined the class person as abstract, at which point will I have the errors here? So the question to you, since again, as I said, we define the class as abstract, and as I said, abstract classes cannot be used for creating the objects. Yeah, we cannot instantiate the objects from them. So where will I have the issue here? In the main program. Yes, if I try to create the object from the class, so at this point, I guess I do not have any statements, a new person. So that's why, yeah, that's correct. We just double check if I have any other statement now, yeah. So let's check, and we'll see that we will have the, we should have the error at this point. This will be, of course, compilation error. There are some runtime exceptions which will occur when the code is executed, and there are also the errors which occur on the compilation point of view. On the compilation point. I'm just mixing some stuff in my head. Okay, so here we go, and here we have the issue what I just mentioned, and yeah, so here it is set, line 51, cannot create an instance of an abstract class, yeah? So just every time you see abstract class, please know that you cannot create the object from them. But what we just noticed? We just noticed that we have employee class, which is inherited from person, and yeah, maybe if I comment out this thought, you'll see that everything will be fine. Everything will work correctly. It will work the same way as before. So we'll see it now. Just no compilation issues. Everything will work the same in a part of this point. Okay. So you can see that everything works as before. So, and what we actually see, we actually see that we have the class employee, which is inherited from person, but so it is not abstract. Yeah, so we inherit from the abstract class, but we do not define the method, the class as abstract. Yeah, so in this case, if we inherit something from abstract class, then we just simply use the same class, yeah, without any restrictions. Yeah, the only thing is that it is inherited from another class. At this point, we are not really interested if we inherit from abstract class or not, except from the point I will mention right now. So that's the abstract class. The first point, the first key thing is that we cannot instantiate them. And yeah, this is why it's called abstract. Yeah, it means that it is used for something. Yeah, it can be used as the type. Yeah, so as you remember, we still can use this as the type. That's not the problem. Again, I do not create the object. I cannot instantiate the object. I just simply pass it to the variable person. This can be done. Remember that when we just simply define the variable, we do not define the object. We define the variable, and then we can pass the object to this variable, the instance of the object to this variable. So this is correct. This is correct. This is not prohibited. Yeah. So again, as I said, first point, cannot create the object, and then why we need it. So just to point to those who write the code that this particular class cannot be used for the object creation. Yeah. So that's first to point to the programmers, but that's not the only point. That's the first point. Yeah. The second point is that we can create abstract methods. Yeah, abstract methods of the inside this class. And what does it mean? It means that this is the method without the implementation. And so we can define the method, but we can skip defining the implementation. So in this case, let's take this one and let's define it as abstract. And we can define abstract method. Yeah, of course. Then I can do this way. Yeah. So at this point, we can see that it does not have any implementation. Okay, so I can write the comment here. Abstract methods do not have the implementation. Yeah, again, please take a look on the fact that we actually have non-abstract methods inside the abstract class. So we can have abstract methods and we can have also the simple methods. In case we have simple methods, so they will work the same way as usually the class. So the question is now what for and when we use such abstract methods. Yeah, so that's a good question, and this is what I will try to explain now. So first of all, again, abstract class is used as the templates for the subclasses. So in fact, these are the same classes, but they should be used for the subclasses. Then we can create the objects from them and basically use all the structures from here as the template for the subclasses. But the class itself should not be the object. But why we need the abstract methods? Abstract methods are needed to, again, simply define them as simply define the methods in case we do not know in particular case what to implement there. Of course, sometimes you can simply keep the, let's say, empty implementation. That would be this way, and of course that can be fine. Yeah. So imagine that you have the case when you have the method for one particular class, but you are sure that this method will be overridden in the subclass. Yeah, so you actually have no logic to write here, and you know that you can only write the logic in the subclasses. So these are the cases when we need abstract methods. Yeah, so in a case we are sure that the method can only, if the implementation, of the method can only be defined in the sub class, subclass, which is not abstract class itself, not the abstract class. Then we use abstract methods. Yeah, so in case we want just simply to define the signature of the method, yeah, without any implementation. Again, why it is needed? Because in some cases we need the class, which again cannot be used as the object, but then we point that there should be a subclass which implements this particular class and use all the methods and all the attributes from this class. The same is for the abstract methods. If we define the method as abstract, it means that the subclass should redefine that method. Yeah, so we force the developers to override this method. Yeah, so it means that they cannot use the implementation of the method from the superclass. They should use the implementation. They actually are forced to use the implementation to define their own implementation in the subclasses. Yeah. So here again, I can simply put the empty implementation in the simple class, but again, if you have the just simply empty implementation, of course, that does not really make sense, right? If you just simply define the method as just simply empty implementation, right? But you may have such cases. Yeah. On practice, you may have such cases, like let's say, for example, from my experience, there is so yeah, also the case there are two classes which so from my experience there are two classes which are responsible for I don't remember which actual business process that was, but so which are processing something. Yeah, so let's say that that's incoming order from the customers, and so it is processed by one or another class. Okay, so let's just imagine we have the class which is responsible for basically which is used as the object, yeah, for some kind of processing for the order from the customer. And let's say that for each country, so let's say that we as the business, we work on, let's say 5 countries. So it would be, for example, Netherlands, Australia, Germany, Italy, France, for example. Yeah, so we have 4 or 5 countries there, and then for each country, we basically have kind of a unique implementation for some methods. However, we have also some methods which are similar for all these 5 countries, which actually the structure, I mean the technical structure, I mean the definition of the methods, the signature for the methods is the same for all these 5 countries. Yeah, so again, yeah, we have, okay, maybe I'll not draw this time, but let's say we have 5 classes. Each class is responsible for each country, but for these classes we have, let's say, some common methods, yeah, with the logic implementation, and then we have the methods which are defined again for all the classes, but for each class the implementation is different. Yeah, so for 5 classes we have the same method with the same signature, but without any common logic. Because for one country there may be one calculation, for another country we may need to do something else. So for different countries we may have this different implementation. So in this case, the obvious thing to do is to use abstract class. Yeah, so I'll create the abstract class, which then will have the methods. Yeah, the methods with the implementation, which is the same for for all the 5 countries, or at least maybe for major countries, or yeah, or at least for major countries, which is the same or partially the same. I can reuse for major countries. So then in this case I create a simple virtual method. I can reuse then for some class, but for some classes, for some methods, I don't have any implementation which will actually be at least similar in all the 5 countries, for all the 5 countries. So in this case, I will define, but the method will present in all these 5 classes. So what will I do? I will just simply define abstract method. Yeah, when the signature is then will be used for will then be used for all these 5 countries I mentioned, for all these 5 classes. But then for each class, I will define a separate implementation there. And yeah, so then I will proceed. And this method and this class in general will be used as the template for my subclasses I define. Yeah, for the 5 countries I just mentioned, and that's why we need abstract class. So at this point, what's the issue we will have? First of all, what's the point about the abstract methods is? So just before I start talking, let's run the program. Let's run the program here, and we'll see that we'll have the compilation error. And the error actually is related to the fact that the abstract methods must be overridden. Yeah, so in this case, and yeah, by the way, abstract methods by default, not by default, but they will always be virtual methods, because we must override them in the subclass. And in addition, it means that abstract methods cannot be private. Yes, since we must override them in subclasses. So, and then I need to do it. So I will override the method here. Here I can write the comment. Here we override the abstract method. Yeah. Okay, so and at this point, does person class have any other subclasses? So let's check. Yes, it does have. It has the class kid. So at this point, we still are not ready to go because we did not override. We have not provided the implementation for kid class. Yeah, so kid is inherited from person. So it also means that it inherits all the methods the class person has. However, as I just said, class person also has the abstract method, and all the abstract methods we should override all the abstract methods here, and that's why it is still not correct. So then I need to correct this issue, I need to override the method here again. Then I say public override, and here I have the suggestion for play. And yeah, by the way, so here I can throw the method, throw the exception. By default, it shows me the exception not implemented. So it means that if I call this method from kid object, then this exception will be triggered. But in this case, maybe let's skip this. We'll maybe talk about exceptions a little bit later. And here I can say that the kid is called the kid is playing. So this is the point. This is the point, and right now I guess we should not have compilation errors. see. Okay, yeah, so now you can see that everything works fine. So yeah, that's the point about the abstract methods and abstract classes. So again, just to summarize, first thing, abstract class is practically the same. I mean, we can do almost everything what we can do with the simple classes, create the methods, define the attributes, define protected private public methods and attributes. So everything is the same there, except several things. First of all, we cannot create the object from the abstract class. And yeah, by the way, we can also create the subclass of the abstract class can also be abstract class. So in this case, we can also follow the hierarchy of the abstract classes, and at some point we can create the abstract class. At some point we can create the class which is inherited from the hierarchy of the abstract classes. So in this case, the class will simply take everything from the superclasses, which will then be, which are then defined by as abstract classes. So that's the first point. We cannot instantiate them. Second point, that we can create abstract methods. Yeah, abstract methods. And in this case, abstract methods means that this is the method which does not have the implementation. So we simply define the signature of the abstract method. I mean, the signature means if it's public or protected, then the returning type, and then the here, and then of course the name of the method and the parameters what we can provide inside. Yeah, that's the point. So next point is that all the abstract methods must be overridden in the subclass which is not abstract class. If the subclass is abstract class, then again we can skip implementing, then we can inherit further, and at the point when the class is not abstract, but it is inherited from abstract class, then all the abstract methods must be overridden. We must define the implementation there. So that's the point. So again, abstract class, the only usage of the, not the only usage, but the usage of the abstract class is that we use it as the superclass. Yeah. So again, remember that we can have only one class from where we can inherit. Yeah, we cannot inherit from multiple classes. We can inherit from one class, so it means that every class can be inherited from the abstract class, but then we cannot inherit from any other class. And so abstract classes can be used as the superclasses, and this is where we use them. So this is the point. And the last point I also want to mention, also from my experience, where we can use the abstract classes as well. So again, abstraction means something special for the objects. From the static methods and static attributes point of view, there is nothing special for the abstract classes. Yeah, if we use only static methods and static attributes, then there is no difference if you use abstract class or simple class. And in some cases, also from my experience, I can define the method, I can define the class abstract as abstract, and then I will simply define all the methods as static. And so I have the class which has only static methods. In this case, I can simply define it as abstract class. Because all the methods will be available. I do not need to instantiate the class because I have all the methods static and attributes static, so I don't need to have the object there. And that's all. So I don't need to have the object, and I can just simply access it as all the static methods and attributes. So do you have any questions about the abstract classes? Okay, just if you have any questions, please let me know. We can discuss them further, and let's maybe have 10 minutes break now, and then we will move to the interfaces. watching. And yeah, so regarding the practical tasks on abstract classes and interfaces, let me I will maybe try to prepare something to you. So I'm not sure if today or maybe before the next session. Let's see how it goes for us there, because I guess before we switch to the data structures, I think we should have some practical tasks about interfaces and abstract classes. So yeah, about the abstract classes, just in case you have any questions, please let me know. But yeah, I will promise that I will find some practical tasks for you, so you can check it by yourself. The next thing, which is, yeah, so basically what we can see for the abstract classes. Abstract classes can only be used as the, wait, sorry, my microphone is muted. Yeah, sorry. Yeah, so, strange. Okay, never mind. Yeah, so what I just said to mute microphone is that I will try to prepare some practical tasks about abstract classes and interfaces. So I'm not sure if I'll manage to do it today or before the next session. Let's see how the time goes for us. Yeah. So and yeah. Then before we start, before we have a practical session about the data structure, I would like to first to have some small practical tasks on the abstract classes and interfaces before. So before we switch to the data structures. Yeah, I'll prepare and I will share then the task with you. It should be small tasks, nothing special there. Yeah, so this is about the abstract classes. So yeah, let's continue about talking about the interface, abstract class and the interface now. So first of all, about the abstract class, what we just seen? We just seen that, yeah, how can we basically use the abstract class? The thing is that the abstract class can be used as the only as the superclass, and yeah, so just as the superclass. But let's say that, and there was the question from last session, so I don't remember who asked it, but the thing may be that let's say that Kit is also a programmer. Yeah, so what should we do in this case? Yeah, so let's say that we have the class parent, and the parent cannot. Sorry, no, the parent is not correct. But let's say that we have the class son or daughter or sister or brother or whatever it is. Then we can apply this to programmer. We can apply this to Kit as well. But the thing is that we cannot apply it to all the classes. And yeah, so let's say that there is some kind of structure what we can apply to Kit and to programmer both. So this is not what is specific for employee maybe, but this is specific for programmer and Kit only. So cannot really imagine such parameter at this point. So. But yeah, so if you have any idea what kind of property we can add to Kit and to programmer, but not to employee. So this would be, oh, okay, I guess that would be maybe learning. Okay. So learning new stuff. So learner. So then let's say that we have the so we say that we want to add the characteristics for learner. Yeah, so for the person who learns, yeah, maybe employee works, but let's say the programmer and Kit, they learn something, so they always learn something new. So let's say that we want to add this parameter to Kit and to programmer, and not to the other classes, but we still want to keep this inheritance starting at human class and finishing at programmer and Kit class, finishing at programmer and Kit class as well. So at this point, how can we proceed? Again, as I said, we cannot have, the thing is that we can only have the superclass and we cannot have multiple inheritance. But let's say that we want to have a superclass plus we want to have something more, and it's a small characteristic. And let's say that then we can create the interface. So here we go, and here I want to create the interface. That would be, let's say, learner. So someone who learns. And let's say that we want to apply this property to programmer and to Kit, to programmers and to Kits only. Yeah, again, in theory we can also apply it for many other classes, but let's say that at this point we just want to apply this for Kit and for programmer. So then what I need to do, I need to define, again, I have the option to define the class, and I also have the option to define the interface instead of the class. So that is the interface, and the interface we should normally start at I, so just because of the naming conventions, and then that would be, let's say, learner. So the person who learns. So the person who learns, and then this can be used. So basically, what are the interfaces? The interfaces, in fact, yeah, just from easy definition point of view, these are the abstract classes where where all the methods are abstract, and we cannot define the attributes. Yeah, so for example, let's say that if we want to define the attribute, say kind of attribute here, sorry, then it will not be possible. We will have compilation error, and so the attributes cannot be defined. The only thing what we can define here is the signature for the method. So that would be, let's say that, yeah, in fact, all the methods defined for the interfaces, they are from the abstract class point of view, they are abstract methods. Yeah, so in this case, and again, for the abstract classes, please remember that all the abstract methods should be protected or public, because otherwise we cannot implement them, right? Because we can only access directly protected or public methods. We cannot access private methods in the subclasses. That's why the only way how we can define abstract methods is that we define them as public or as protected. But that makes sense. Otherwise, there is no way of using them. No way we can use them. So yeah, that's the point. And here for the interfaces, the rule is the same. I can only define that. In fact, I guess they can only be even public. Yeah, they cannot be even protected. But yeah, so in most cases they're used as public, and I guess we can skip even defining the access modifier. We can just simply name the method. So the method would be, say, learn, and then this would be the method. And so from compilation point of view, there is nothing more to define. So just let's check if no compilation issues are there. Let's check. Yeah. So no issues. Type something here. Yeah, and so let's then implement this interface again. This is something similar to abstract class. However, yeah, so here all the methods are what we define. I can define more methods here. So we're going to say void share knowledge, and so here I can share the knowledge with another learner. Yeah, so remember that the abstract classes and also the interfaces can also be used as the data types. Yeah. So it would be, say, another learner. Yeah, so this signature simply points to me that this is the method which will share the knowledge with other learner. Yeah, so then it is defined. Yeah, so I have the interface with two, from the abstract class point of view, these would be abstract methods. So what does it mean? It means that I simply need to override them in the class I use. Them. So where we can use the interfaces can be used under the other interfaces. Yeah, so it means that the interfaces can also be inherited. Yeah, so one interface can inherit another interface. And the normal case, not normal, but the most usual case would be that the interface is assigned to the class. So what this means that I assign the interface to just any class I want, then these methods will be available then for that particular class where I assign this interface. Plus, the same as, the rules about the inheritance, they stay in place. So it means that if I assign this interface with these methods to the just any class, then they will also be inherited they will also be inherited in the subclasses. So the same rules as for abstract methods and the same rules as for the all the simple classes. So then the next thing is, how can we actually assign the interface to the class? So yeah, what's the point? We can have only one superclass. However, we can have as many interfaces as we want. So let's say maybe I'll skip it for employee, but I will then assign it to the class kit. So then I guess I need to define it this way. And at this point, the same as for the abstract class, I need to redefine this interface. Well, not redefine this interface, but redefine and override the methods, which are defined in the interface. At this point, we'll see it will have the compilation issue, which will ask us to define the implementation for the methods. And so here I see that I need to define the implementation for learn, and for share knowledge. So what does it mean? It means that let's then I need to redefine this method. So it will be public. Then I have white, and this would be a public override, of course. Yeah, by default they are not by default, but the methods defined in the interfaces, they all are virtual by definition. So that will have public override. And I'm not sure why it's not suggested. Okay, maybe because I defined. Maybe I can skip. Then use public, and then I have the method learn. I'm not sure why it's not shared here. Strange. Okay. Let's see. public override. Okay. So, and here I can share the knowledge. Then I can say that I'm learning how to eat, walk, and let's say what kids can learn and how to play, maybe how to play games. So, and that's the same for knowledge sharing. Public override, that would be void share. I'm not sure why the compiler doesn't suggest me. Okay. Share knowledge, and here I can pass the information to whom I want to share the knowledge. It will be another learner. Here I can write that. So not only I can write in theory, I can do some actions there, but yeah, so let's say that I'm sharing my knowledge with, say here I can pass the information about the learner. So let's say if we have any compilation issues now. Okay. Not sure why it's not shown as here on normal. That's strange. And okay, yeah, so that's fine. Yeah, okay, then I don't need to write override. Yeah. So I forgot that yeah, someone just need to write override for the interface methods for the in C# you don't need to write an override. Yeah, now everything's fine. Yeah, so just one point that for the interface methods you don't need to point override, you just need to implement them. Yeah, so that's the point. That's the point, and now actually I define them here, and then I can also I can assign this interface to the person or to the programmer class. So then I can define it here. Yeah, again, we can have one superclass, but we can have multiple interfaces assigned. So not person, but the programmer. So, and then we can simply need to separate them using comma. And here again, at this point, I will have compilation issue since I don't have the implementation of them at this point, but I define that programmer is learner, but I need to implement the methods here. So at this point, let me then write it here, and here I can say that I'm learning how to, let's say, write Good code. Very good code. So unshare knowledge. I'm sharing my knowledge was under learner. So at this point again, we will not have any compilation issues. So yeah, and this is what the interfaces are about. So practically the same abstract classes. However, we can assign multiple interfaces to one class. Yes, so I can create more interfaces and then assign them to one class. And then it means that I need to override all the methods from, not override, but implement all the methods from this particular interface I defined here. Okay. So that's the point. That's the point. Do you have any questions about the interfaces? Okay. I can search for some practical tasks. Yeah, I would like to maybe go for some practical tasks here about the interfaces and abstract classes. Let me check if I do have such. Let me check. Yeah, let me know if you have any questions about the abstract classes. Okay, so in case you don't have, in theory we can switch to the collections practical, but okay, then maybe before today we can proceed with the collections practical task. I hope that this won't be a huge problem, and then before the next session I will prepare some tasks for about the inheritance, about the abstract classes and interfaces, and then we'll proceed with the practical part on these topics next time. So today we will then go with data structures, and basically data structures are mostly based on the interfaces and abstract classes. So for example, if we talk about the list, then the list itself is not the full class. That's the so if we go to the let's define a folder here. Not under here. Define a new folder. So that would be data structures. So I'll get to that folder. So let's define a new project here. Okay, now the project is created. So now I can proceed with the assignment. So first of all, I will start with the first assignment. And let's see what do we have. So one program for actions was array list. Please take a look. Yeah, okay. We actually already worked with the array list, so that should not be a huge problem for us. So let's then implement this. Yeah, so currently I'm working on the practical assignment data structure, assignment number 1. So let's then proceed together. Just move. And yeah, so let's start with task 1. Task 1. So you know how we can do? We can actually So just to make it easier, to not define the same thing, but to not define multiple projects there, what we can do, we can simply keep every assignment into its separate let's say separate file or separate class. So let's say that here I'll start with assignment 1, and from here I can create practically another running method. So that would be non-static. First, so that would be, say, assignment 1, and from here that would be not, in theory, it's not defined as static void main, but that would be, say, start or run. So that would also be static, and from here then I will run the first task. In addition, I can ask user to, for example, let's say that I will ask user to ask user which assignment should be executed. So here this would be, say, assignment number. Let's initialize it as 0, and then let's say I will ask user which assignment should be executed. And should be executed. So in this case, I can ask user to provide the input. Here I will say it will be try parse as usually. So that can be true as always. And here we can say, here we can then try to parse. Try parse. So here this would be the input. And out will be assignment number. So then if try parse is false, that's true, then we exit the loop. Otherwise we say that please repeat the input. So as to just check the input. Okay, once the input is done, then we can do the switch here and check which assignment which assignment we want to run. So let's say we have a switch statement. We'll switch on the assignment number. Say that case 1, I will run the first assignment. So that would be assignment 1, and from here I can simply run the starting method here, just to make it more ceremonial. I will find it as public here, and then I will run. And then I'll say break in the case default case. So I will then say that. So if the number is not 1 in this case here, then I will say that such assignment does not exist here. So and from here I can simply ask user which assignment runs. So when I have the task 2, I will then do the same for case 2 and so on. So that's just the easy option to then basically write all the assignments into one program. And then the user can just simply select which program to execute, and then this can be provided from console. Okay, so now let's start implementing the first task. Again, I can have this public static void here, and then I can have multiple other methods which I can then use to define my object. So let's then start. First of all, it asks me to create a string array with following values. Okay. Okay, that is from the string materials. And then just write the same code using the array list class for the value storage. Okay, then from here I can define array list. Yeah, please remember that the array lists are imported from the, not from the system, but from the system collections, right? Not mistaken. Then from here I can define the array list, take a variable, and so here I can simply say that here so again, the array list, that's the object, so I need to create it as object. Here it is done, and then only after that I can put the values there. Okay, so here I can this one, sorry. Here I can add these values. Yeah, by the way, we can see that there are different implementations of the constructor. So it's unparameterized constructor, and there is also parameterized constructors. And like collection constructor simply means that we can define a new object by providing the values from the previous collection. Yes, so it means that we can create one array list, then we can pass these values to the new array list. Yeah, so here we can these values. So we have computer, then we have plate, then we have chair, we have girl, and then we have boy. We have cat. Then we have dog. I am short. Shirt. And we also have the determination. Okay. So then we just need to implement the same actions using array list. So first we need to find how many values are starting with C. So first let's check what are the methods we can use from here. We can use binary search. That's in case we are searching for the value. Yeah, so in this case we must be sure that array list. So in case we want to use binary search, as you remember, I explained to you once about the binary search. So it means that again, so about the binary search is only needed can only be used for the sorted collection. This is because again, let's say that we have sorted collection and we want to search for one particular value. So if the collection is not sorted, then the only way how we can search, we need to then go through all the elements. So just to find for one particular. But in case we know that the collection is sorted, then in this case we don't need to check all the values. We can use smarter way, and we can spend less time. Again, for sorted collection, sorted list, what we need to do, we can split. What we can do, we can split the collections in two. Yeah, so just split collection in two. Then we know that on the right side we'll have the greater values, and on the left side we'll have smaller values. So in case we're searching for the value which is greater than the middle, yeah, the middle value of the split in between two elements, in between two sections of the list, then we go to search to the right side. Otherwise, we go to search to the left side. Yeah, so in this case, it takes less time and it's more efficient to search. But yeah, so we'll not maybe touch to this point since we don't have sort of collection. So we can clear. We can check if the collection contains particular element. So yeah, get range. So get range. This is also not so interesting for us. So yeah, it's nothing really special what we can use for this point. Okay, so then we need to go through all the elements of the collection and find the right element. So in this case, we can practically copy paste the logic from the segments about the string. So segment number 1. And here I can simply can also just simply copy paste the code from here. So that's the segment number 1. Oh no, hold on, that's the regex. Okay, that's the segment number 2. So there was the typo. So and here I can basically copy paste the code needed for that assignment, and then I can use this code here. And some adjustments are needed. First of all, just maybe let's check what are the adjustments we need here. So the compiler will tell us. So have some issues, and let's just go one by one. Oh, that's hold on. We not under the okay, that's just jumps too far. So here we have 125. So and oh yeah, of course. So to access the element, oh no, that's program CS 25 20 case label. Oh, hold on. So what's the issue here? Let's also put break here, but we cannot fall out of switch from final. That's strange. So what's the point here? Okay, then maybe let's go to the assignment. Just fix this issue. So name doesn't exist. Okay, and yeah. So instead of array, we have array list here. Okay, so we need to then adjust it. So I can search for array. And do the adjustments here. So here I can do some adjustment. Okay, and yeah, that's it. So let's check again. So object something induction. Okay, that's for the length. So here we for array with we don't have length, but we have hold on. Okay, we do have length. What's the point? Okay, I got it. I got it because moment. That's what's the issue here. Of the string. So element is actually the string. So it's okay, it says 143. 43. Okay. So that's the point. That's the point because here we need to then use string instead of bar, because for array width, again, as you can see, we do not define the type. So in fact, we can also point it here for the array width. We do not define the type for the array width object. We do not define the type. We do not define the type, so we can put any object inside. Any object, any value inside, and with any type, without any restrictions. So that is why if we use var, then var, then it means that the type will be object. As you remember, we have type object, which is basically the super class, super type for all the objects in C#, for all the classes in C#. And that's why, in fact, we can also say that array list simply, so in other words, we can simply say that all the, not all the, but that the type object is allowed for the array list elements. Yeah, so that would be the same if we define. So again, as you remember, for the arrays, we define the type. Yeah, so if that's the array string, then it means that the string elements should be there. For the array list, that would be the same as if we define the object type. Yeah. So if we define the object type, yeah, we can put it, maybe write it this way so we can understand it. We'll define the object type, and then I can put any element there without any restrictions. But what's the point would be? The point would be if we have object type, then again, as you can see, as you remember from the definition about the inheritance. So if we inherit something from the superclass, then here we can add some more methods, yeah, or public methods which then can be used. But if we use the variable, which is the superclass, which is taken from the type as the superclass, then we cannot call these methods from this variable. Yeah. So that's the point. That's the point, and that's the difference. So again, even in fact, when we use string, if we pass string to the variable type as object, then we cannot call the specific methods what we can do for the strings. Yeah. So that's the point, and that's why if I use var, I will get such issue. Okay. So do you have any questions so far? So at this point, let me run the program. Let's see if I don't have any issues. Okay, assignment 1 negative. That's okay, we don't have compilation error. and the histogram is printed as well. And what else do we have? And all the other methods basically work the same way. Yeah, so in fact, the same code as with the strings, or as with the arrays, it can be simply used for the array list case. Yeah. So the same code, same definitions, same usage, but more flexible since I don't need to know the size. Yeah. And even if I need, I can add more elements. Okay, so do you have any questions so far? So, and then I also have so there's also one more point, sort all array list values in ascending order by the first letter. You can choose any of the sorting algorithms, but the resolution should be your own. Some algorithms, yeah, we can check some. Okay, then maybe let's sort using the simple bubble sort. So in this case, let me define this method here. Be private, say static, void sort array list, and here I can pass array list, and so I can say it's the list, and here I need to sort it. Right, so how should I proceed? How should I proceed then? So let's maybe implement simple bubble sort. So that would be the easiest one. So the easiest one, and let's then do it. So let's start for each list, for each string element in list. I would need to go through all the. Oh no, hold on. Here we have. Here we will need to use iteration. So that would start at 0. I equals 0. I is less than 1 of the list. So the same as for the array. Oh no, hold on. We have the the one, but yeah, actually, if you want, you can also sort it. So, but in this case, yeah, that won't be your own implementation. That would simply be the generic one. Oh, hold on. Moment, so I don't see the method. Okay, we have count. Sorry, yeah, but count. I forgot about it. Yeah, thank you, Lena. Yeah, that's count. Yeah, it's in so many different collections. Also, from my experience, I faced length, I faced size, and yeah, also I faced count. Yeah, so that's why I'm just. Yeah, thank you, Lena. Yeah, I was just forgot about it. Okay, let's count. And yeah, that's I. And I plus plus, of course. Okay. So that is count, and here we go. Here we go. Then remember bubble sort. Just need to push the biggest element on top, and I need to go through all the elements of the collections of the list one by one. So then I need the second one, and here this would be not I, but say J, and it will start at the next element. So the next element will be I. So, and of course, here we'll have count minus 1, since we don't need to touch the last element. And. Yeah, so then we will push the elements then to the top. Oh, however, no, sorry, we need to start at one moment. No, we need to start then at 0. Start at 0, and then we'll have not length, but west count. Oh, hold on. Yeah, then we need to start, and this would be count west minus I. Yeah, so here we go. So then we need to check if yeah, here minus no, not minus one. Okay, so here we start with max element, and we say that we'll have string max element, and yeah, so let's think that that's the first element. The list was I. So what again? What's the point of bubble sorting? Is that I need to push the heaviest elements to the top. So that's why I need to go through all the elements and check if the element is bigger. Then I need to swap it with the next one. And then this is the same for all the elements then. Okay, so here we go. Oh no, sorry, not the max element. Just yeah, I don't mean max element. So yeah, then I go through all the elements and then I check. So if the so it will be minus one as well. Minus one. And then I check if west j is less than count. No, sorry, not count, but j plus. No, if it's bigger than j plus 1, then I need to swap them. And this would be string current, let's say. And this would be list j. So I keep this value, then assign it to the next one. No, not at all. Then assign the next one to this one. So this is the way I'm swapping the values, and then list j plus 1 will have the current one. And so this is the way I swap the elements. And then it means that I push the heaviest to the top. Yeah, so then this will be done. And I guess the iteration is then fine there. Okay, so here we go. I guess that was fine. Let's check the result. And yeah, also let's print the array list. So let's print. I'll create a separate method. And here I'll go for each array list. So that will be the string again. Item in array list. And here I will print the element. space here, just to separate them. Okay, so let's see what will we have here. So for hold on. Oh no, that will be fine. Yeah, that will be fine because the arrows are the objects. So if I pass them to the methods, then if I do any changes on them inside, they will automatically reflect the changes after doing. So and here I can first of all call the sorting. So let me start with sort. So the array is defined here, right? And then I need to print it. Yeah, if you want, you can skip using assignment 1 and just write it to maybe make it more understandable that I call the methods exactly from this class, not from anything else. Yeah, so that's why I use this prefix. But if you want, you can simply write it this way. This will always also be correct because I'm inside this class. Yeah, but just as you want. So that's one. Let's check if anything is wrong. If anything is missed. Okay, something is missed. Oh, that's. Did I use VR again? So that's the line 18. Okay. Yeah, okay, then here I'll need to then do the casting operation. Since here I use array list, but array lists are they are used as the strings or as the objects. Okay, and also for comparable. So since yeah, that's a good point as well. So again, array lists, they store the objects. They do not understand that they actually store the strings. So in this case, how can I proceed? I can convert them this way. So then I will do the casting here. I will do the casting here. From here, so this is the string. Here I can then try to compare them this way. So that's such kind of strange syntax. Such strange syntax, I guess that should normally work. Let's double check. Okay. Oh yeah, for the string that still cannot be applied, but for the strings we can just compare to, and then compare to will then return, it will return 0 if they are the same. They will return -1 if it will return -1 if the comparison is less, and then it will return +1 if comparison is bigger. So in this case, we are checking if the comparison is bigger, and we need to say that it is greater than 0. So let's check. Yeah. Then I execute the first assignment, and so what does it do? Okay, so it seems that I have the issue in the implementation. Okay, so let's check what's. Oh, yeah, so that's the problem. Of course, here I need to pass current. Yeah, my fault. Sorry. Yes, here, of course, should be current. Yeah, just the wrong swapping here. So if you spot that something is wrong, then let me know. Here. Let's stop and run. just the issue in the swapping operation. Let's check now. So now seems to be correct. So just a small, yeah. So you may be confused what's happening here. So first of all, for string has compare method, compare to method, where we can pass another string to compare. So in this case, what happens? If the string passed is smaller, then the value for 1 is returned from method. Otherwise, so if the string passed is greater than the current value from where we call the method, then the value -1 is returned. If the string passed has the same value, then 0 is returned. Yeah? So that's the point. That's the point, and this is what we have here. Yeah? So then 0 is returned. And in this case, what we have, so first we'll do the casting. Again, in theory, I can do the casting using the separate variable. In fact, I can also do it directly here. So in this case, I cast list j to string. Again, since list it contains object types only, then I need to cast it in some way to string. Yeah, because at this point the program does not understand that we pass the strings only to the array lists. Yeah, so the program does not know it. That's why the program wants to be clear and then asks us to do the casting there. And that's why we can do the casting here. And then when we cast it, so at this point the program knows that we use the string, and then it has compared to a method, which then where I need to pass the string, and again to pass the string I need to pass the object to string. And so here I have the downcasting, but I'm sure that this is correct because the values are provided the values are provided from here, and I'm sure that they all are strings. Okay, do you have any questions about this task? So again, all the other things are the same, but please note that inside the array lists, the data type is object. Yes, so it means that no special values I can call from these objects before I do the corresponding downcasting. Yeah, and downcasting means that I cast them from more general type, data type, which is object. Yeah, because again, all the elements for the array lists are the objects, and then I cast it to more detailed type, more specific type, which is string in this case. Okay, so that's the point. Do you have any questions then about this one? So then, if not, you can start working on them. So that would be individually. This would take more time, I think, but so this is not just an urgent. So the plan is that you can start working on it now. So we'll implement it. You'll implement it individually. I mean, of course, with my help during the sessions. But the plan is that today you're supposed to just take a look on it and start. And then next time we will we will start with the practical tasks on inheritance and abstract classes. Again, I have not prepared them yet. I'll prepare them before next session and then share them with you. So then we have some practical tasks on on abstract classes and on interfaces. And then after that we will switch together to this task. So before if you have time, so also just for the next session, so then we can write this out. So first of all, here we have the algorithm on the graph. In fact, for the graphs, we can so the graphs are the objects. We can consider them as the objects. Of course, if you want, you can implement everything as static. That's not prohibited, but normally we should implement the graph as the object. So, and what we have for the graph? For the graph, we have the vertices and the edges, right? So, what does the vertex have? Vertex has the name, and the vertex has the edges, the roots from this particular vertex, from this particular location. So let's say we have a graph. It is just the object which collects all these vertices and edges. So at this point, just my suggestion for the implementation would be that you have the class which defines the structure of the graph object. Then for the graph object, you will need to have, let's say, two collections. You can use array lists, you can use linked list. Just the decision is up to you. Then inside these collections, so inside one collection, you need to put the vertices as the objects, and you will need to put the edges in another collection. So we have two attributes. One will be edges and another will be vertices. And of course, you also need to create the classes for vertex and for edge. So what will the class vertex has? It will have the name of the location, and what else do we need? So at this point, maybe it does not really need much, but that's up to you. You can implement it in the way that the vertex will have the name, of course, and it will also have the edges and the roots from this particular vertex. Guess it is not really required here, but I suggest that would be easier. And then you have the edges, the list of edges, and then you have the class of edge, and edge has just simply two parameters. One is vertex 1 and another is vertex 2. Yeah. So let's say that you have the class. So you have the class vertex, it has the name and the roots from this. So then you have one particular object. That would be windhook, and then from here, so the name would be windhook. Then it will store the edge. It will store this edge as the object. Then we have this edge as the object. It will have two vertices. Yeah, so vertex 1, vertex 2. It doesn't matter which one's first one, which one is second one. And then vertex 1 will, let's say, will be this one. Then vertex 2 will be this one. Okay. So and then this root will be here. So what we need to do here, so we need to then define basically these classes, yes, and then create the graph based on these this picture and this image. So I need to print out all the elements of the graph, write an algorithm, calculate how many direct flights are in the graph in total. So how many direct flights there are? Basically, you need to just simply share the number of the edges you will have, then print out all outputs which are connected to data. Yeah, so and with direct flight Right, and after that, focus calling the files are from Geowork Airport. Okay, security also calculate. Okay, so this is the task. We can start working today, and then we can continue. Then we'll continue this on Wednesday. So is the task clear? Do you have any questions? So then if the task is clear, so please start working. I will be available, let's say another half an hour now, and then just ping me in Discord, and then I will help you with your questions then. Okay. So maybe at this point I'll have, let's say, kind of 5 minutes break, and then after that I will be back to help you with this task. Okay. Just let me know if you need help. I'll be here. Just in case you have any questions, please let me know.